Hello everyone, welcome to Neso Academy. We are studying machine learning pipeline, and in the previous lecture, we have already understood the first two steps of machine learning pipeline, that are problem definition and data collection. Now in this lecture, that is data cleaning, we are going to understand and practically implement the third step of ML pipeline, that is basic data cleaning or simply data cleaning. So the topic for this lecture is data cleaning. This is the machine learning pipeline that we are studying, and we have already defined the problem statement and we have already collected the data. Now it's time to apply basic data cleaning over the data that we have collected. Let's get started. What is basic data cleaning? Fixing obvious problems in raw data before data splitting is known as basic data cleaning or simply data cleaning. Let's understand this point. In the previous step, we have collected the data. Now that data is actually real-world raw data. So it can be messy, unstructured, unformatted, and inconsistent. That is why we are required to remove the inconsistency from that data. So, basic data cleaning is the process of fixing obvious problems, or I can say correcting errors in the raw data that we have collected before going to the fourth step of machine learning pipeline, that is data splitting. I hope you have understood what is basic data cleaning. Now, what all operations do we perform under basic data cleaning? The first one is remove duplicate records. So in the data that we have collected, there can be multiple duplicate rows. So we need to remove all the duplicate or redundant rows from our dataset. Second is remove irrelevant columns. Now what are irrelevant columns? There are multiple features in our dataset. Some features contribute in predicting the target variable, while some features don't contribute in predicting the target variable. So we have to remove the features or the columns that have no contribution in predicting the target variable. Such features or columns are known as irrelevant columns. So we need to remove such irrelevant columns from our dataset under basic data cleaning. Third one is correct inconsistent formats. Now there can be some inconsistency in the formattings in our dataset. We need to remove or fix such inconsistencies from our dataset. It can include some spelling mistakes, some extra spaces, some cases mismatch, and many more. Next is fix impossible values. In our dataset, there can be some impossible values. For example, in a house price prediction dataset, the size of the house can contain some negative values, which are impossible. The age of the house can contain some negative values, which is impossible. So, under basic data cleaning, we need to fix the impossible values also and check missing values and invalid labels. So there can be some missing values also in our dataset. We need to check the missing values and we will replace the missing values with the standard invalid and missing values placeholder, that is NaN, not a number. You need to remember that we don't handle the missing values under basic data cleaning. The handling of missing values will be done in the later step, known as data pre-processing. In this step, that is basic data cleaning, we only check the missing values and we replace them by the standard placeholder for missing value in Python, that is NaN, not a number. And we also check for the invalid labels. If the labels or the output variable is invalid, we need to remove the entire row. Because if the label is invalid, then there is no meaning of the entire row. So now I hope you have got an idea of all the operations of basic data cleaning. Now we will take the same house price prediction dataset and we will try to apply all these operations of basic data cleaning over that particular data set. So this is the house price data set that we have, and this data set contains multiple errors. Now we will apply all the operations of basic data cleaning one by one over this particular data set. The first operation is remove duplicate rows. Now, can you see any duplicate row in this particular data set? Yes, these two rows are duplicate rows. See, these two rows are exactly same. That is why we will remove one row. So this is how we have removed the duplicate row from our data set. Now the second operation is to remove irrelevant column. Now size of the house, bedrooms, location, age years, garage. These features of the house contribute in predicting the price of the house, obviously. But do you think the feature house ID or the column house ID will make any contribution in predicting the price of the house? No, not at all. The price of the house will not be depending on the house number or house ID. That means this house ID is an irrelevant column or irrelevant feature. So we will remove this particular column from our dataset. Now the third operation is to fix the inconsistent formats. If you closely observe this dataset, in the column garage, there is an inconsistency in the format. See, this particular yes is written in uppercase, this yes is written in title case, this no is written in title case, this no is written in uppercase, then these three yes are written in title case. That means there is a case mismatch. So we need to remove this inconsistency. Now, these two uppercase yes and no will be replaced by title case yes and no. And now you can see all the values in this garage column are in proper title case, which means we have successfully fixed the inconsistency in the format of this column. Now the next operation is to fix the impossible values. In the column size SQFT, you can see we have 0 and minus 1200. But do you think the size of the house can be 0 or minus? No, the size of the house can never be 0 or negative. That means these two values are impossible values. Also, the age of the house can never be negative, which means this is also an impossible value. Right now, we are only talking about the features of the houses. That is why for a while, please ignore this negative value for the price because it is not a feature, it is the target variable. Now, how to fix these impossible values? These three are impossible values. So how to fix these impossible values? Obviously, we cannot replace these impossible values with any random value because these values will be fixed by a proper logical value through a technique known as imputation. And the technique imputation we will study under the step data pre-processing. That is why right now we cannot replace these impossible values with any other numeric value. So now how to handle these impossible values? We will replace these three values with NaN. Now what is NaN? NaN means not a number. It is a standard placeholder for invalid or missing values. And NaN is detectable by Python libraries. So in the later stage, that is data pre-processing, our Python libraries will detect these three values as missing values and we will apply the imputation technique to replace these NaN with a proper logical value that can be placed in place of these not a number values. Now the next operation is to check the missing values. Missing values can be represented by an empty cell or missing value can also be represented by any placeholder like question mark, null, none, NA or anything like that. Now if the cell is empty, then that will be directly detected by the Python libraries as a missing value or NaN, not a number. But if the cell contains a placeholder like question mark, then it will be considered as a text. That is why we need to replace this question mark with NaN so that Python libraries can detect this as a missing value or not a number. Now, this missing value will also be handled in the data pre-processing stage when it will be replaced by any proper logical numerical value by the technique known as imputation. That is why under the step basic data cleaning, we are only checking the missing values, we are only checking the impossible values. But in the data pre-processing stage, we will actually replace, we will actually handle these missing and impossible values. Now, the last operation is to check the invalid labels. The price USD is the target variable or the label in this particular dataset, and you can clearly see these two are invalid labels because price USD or the label cannot be missing and the price can never be negative. That is why this missing value and this negative value are invalid labels. Now, if the labels are invalid, we need not to replace it by any other value. We will directly remove the records associated with invalid labels. So in this way, we have performed all the operations under basic data cleaning. Now we will go to my computer system to practically implement basic data cleaning over our house price prediction dataset. So now we are on my computer system and you can see I have already opened the Google Colab. In the previous lecture, we have uploaded house price dataset in the Google Colab and we have analyzed the house price data that I have collected. Now in this lecture, that is basic data cleaning, we will understand and implement the various operations of basic data cleaning. And after performing this step, we will get the cleaned data set. So that in the next lecture, that is data splitting, we can split the cleaned data set into two parts, training data set and testing data set. So now we will first take a quick recap of what we have understood in the previous lecture, that is under the topic data analysis. So in the previous lecture, we have imported the pandas library. Then we have read the Excel file, house price dataset, that we have uploaded in the Google Colab. After that, we have seen the first 5 rows of our dataset using the df.head function. After that, we have seen the shape of our dataset, 124 rows and 7 columns. After that, we have seen the names of all the columns of our dataset, like house ID, size SQFT, bedrooms, location, age years, garage, price USD. After that, by applying the info function over the data frame df, we have got all the information about our dataset. So this was all we have performed in our previous lecture. And now we will start the basic data cleaning. In the basic data cleaning, we will follow some steps. The very first step is copying data frame. That means we will make the copy of the original data frame. It is a standard practice in machine learning that we don't manipulate our original data frame df. That is why first we will make the copy of the original data frame df and then we will perform all the manipulations over that copied data frame. After that, as I have already explained you, we will remove the duplicate rows. Then we will remove the irrelevant columns. After that, we will check for all the missing values in our dataset. Then we will fix the inconsistent formats. After that, we will check the impossible values. After that, we will check the invalid labels and we will delete all the rows associated with invalid labels. And after that, we will reanalyze our data so that we can check what all operations we have performed successfully. So let's start with our very first step, that is copying the data frame. The first line is import numpy as np, which means we are importing the Python library known as numpy or numerical Python. Why? Because in basic data cleaning, we are going to deal with the numerical values. That is why we are importing the Python library known as numpy. So, import numpy as np, where import is the keyword, numpy is the name of the library, as np. np is the short name given to the library numpy. After that, we will execute this particular line. And you can see the NumPy library is successfully imported into the Google Colab. The next line is df. So basically, we need to create the copy of the original data frame. So first we will check how the original data frame looks like. That is why I have written df, which is our original data frame. If we execute this line, you can see this is the original data frame that we have. Now we need to create the copy of this original data frame. So I have written, let's understand, data equals to df.copy, which means we are applying the copy function over the data frame df, and that copy will be stored in a new data frame data. That means this data is a new data frame on which we will perform the manipulations. And this data frame is basically the copy of the original data frame df. So data equals to df.copy. When we will execute this line, the copy of the data frame is created. Now let's check the copied data frame. So the name of the copied data frame is data, so I have written data. If I execute this line, we can see this is the copied data frame that we have created. And you can see this copied data frame is exactly same as the original data frame because it is the copy of the original data frame. So in this way, we are done with the step number 1, that is copying the data frame. Now we will perform removing duplicate rows. So the first line is data.duplicated. This line of code tells us whether a particular row in the data set is duplicate row or not. It will return the Boolean value. If the row is duplicate, it will return true, and if the row is not duplicate, it will return false. That is the meaning of the line data.duplicated. So if we execute this line, see, this is the result. That means the 0th row is not duplicated, first row is not duplicated. Similarly, 123rd row is duplicated row. That means we need to remove such rows that are duplicate in our data set. Now, just by adding one more function, that is .sum, we are actually getting the count of total number of duplicate rows in our data set. So data.duplicated .sum means we will get the count of total number of duplicate rows in our data set. So when I execute this line, I am getting 1. That means there is only one row in our data set that is a duplicate row. So now we need to remove such row from our data set. Data equals to data.drop duplicates. Let's understand this line. Data.drop duplicates. Now drop duplicates is a function that is used to remove the duplicate rows from our data set. And this drop duplicate function is applied over the data frame data. And after removing all the duplicate rows, the entire result will be stored in the data frame data, which means the data frame data is getting modified. So when I execute this particular line, all the duplicate rows will be deleted from our data set. So let's check one more time the total count of duplicate rows in our data set. When I run this line, I'm getting 0. Last time the result was 1. But after deleting the duplicate rows, the count is 0, which means now there is no duplicate row in our data set. And we are done with our step number 2, that is removing duplicate rows. Now the third step is removing irrelevant columns. That means we will remove the irrelevant columns or features from our data set. Like I have explained you that house ID is a type of irrelevant column because it is having no contribution in predicting the final price of the house. Now when I expand this particular section, I have written the first line as data is equal to data.drop house ID, comma x's equals to columns. Let's understand this line. Data.drop, which means the drop function is applied over the data frame data. Drop means delete. And what we are deleting? The irrelevant columns. In this particular data set, what is the irrelevant column? The house ID. That is why here I have mentioned house ID. Now what is the meaning of x is equals to columns? X is equal to columns simply specifies that this house ID is actually a column of the given dataset. So now this house ID column will be deleted by this particular line and the result will be stored in the data frame data, which means the data frame data will get modified after deleting the irrelevant column house ID. So let's execute this line. We have executed this line and now the house ID, that is the irrelevant column, is successfully deleted from this dataset. Now the next line is data. That means we are checking how the data frame data looks like now. When I execute it, you can see the data frame is getting started with size SQFT. The first column, that was house ID, is not present over here, which means it is deleted because it is an irrelevant column. Now the next line is data.shape, which means we are checking the shape of the dataset now. When I execute this particular line, I am getting 123,6. Now, when we previously checked the shape of the dataset, it was actually 124,7. But we have deleted one duplicate row. That is why the count reduced from 124 to 123 in case of rows. And we have deleted one irrelevant column, that is house ID. That is why the count of number of columns is reduced from 7 to 6. And in this way, we are done with our third step, that is removing irrelevant columns. The fourth step is checking the missing values. Now to check the missing values, first we will check the total number of entries in each column. So I have written data.count. Let's execute this line. See, I am getting the name of each column and along with that, I am getting the total number of entries in that particular column. Size SQFT has 122 entries. Now the total number of records were 123, but size SQFT is only having 122 entries, which means the column size SQFT has one missing value. Similarly, the column bedrooms has two missing values. The column location again has one missing value. Age, years and garage has no missing value, while price USD has one missing value. In this way, we have checked the count of total number of entries in each column. Now the next line I have written is data.isNull.sum. Now this whole line of code, that is data.isNull.sum, will give us the count of total number of missing values in each column. So when I execute this line, I am getting size SQFT contains only one missing value, bedrooms contains two missing values, location contains one missing value, age, years and garage don't have any missing value, price USD has only one missing value. So data.isNull.sum is a function that is used to check the number of missing values in each particular column of the given dataset. Now the last line is data equals to data.replace question mark comma np.nan. Let's understand this line. I have explained you that missing values can be represented in two ways. First is an empty cell. If the cell is empty, it will be directly detected by the Python libraries as a missing value. So there is no need to replace it with NaN, that is not a number. But if the missing value is represented by any placeholder like question mark or null or none or something like that, then we need to explicitly replace it with the standard placeholder for missing value, that is NaN. So similarly, we are replacing this question mark if present in our dataset with the standard placeholder missing value, that is NaN, not a number. Now why I have written np.nan? Because not a number, that is NaN, is a value contained in NumPy library. That is why I have written np.nan. Data.replace question mark np.nan, which means wherever there is a question mark, it will be replaced in the given data frame by np.nan, and our data frame data will get modified accordingly. Now when we execute this particular line, it will be executed, which means all the question marks are replaced by the standard missing value placeholder, that is NaN, not a number. In this way, we have performed missing values checking also. I have already explained you that in this step, that is basic data cleaning, we are only checking the missing values. But the actual handling and replacement of these missing values by actual numerical logical values will be done in the later stage, known as data pre-processing, where we will actually replace the missing values by the technique known as imputation. That we will study later. Now, the next step is fixing inconsistent formats. So, in the presentation, we have seen the garage column of house price prediction dataset was having some case mismatches. Some values were in uppercase, while some values were in title case. So, we need to fix this inconsistent format. When I expand this particular section, I have written the first line as data garage. What does that mean? This line will simply print the garage column of our original data frame, data. So when I execute this line, you can see this is the original garage column of our data frame, data. Some values are in uppercase, while some values are in title case. We need to fix this inconsistent format. So the next line I have written is data garage equals to data garage.str.title. What does that mean? It means that str.title, that is, the title function of the string, is applied over the garage column so that all the values are converted into title case. And this modification is done in the original garage column. So when I execute this line, it will change all the values of garage column into the title case. Now again, if we print the garage column, we can see now all the values are in proper title case. There are no case mismatches in this garage column. So in this way, we are done with fixing inconsistent format, and the next step is checking impossible values. But before checking the impossible values, let's first take a quick recap of what we have understood till now. So in the very first step, we have copied our original data frame into a new data frame. After that, we have removed the duplicate rows. After that, we have removed the irrelevant column from our dataset, that is house ID. After that, we have checked the missing values and replaced them with the standard placeholder for missing value, that is NaN. And we have fixed the inconsistent formats in the garage column of the dataset. The garage column was having the case mismatches, and we have converted all the values of the garage column into title case. Title case means the first letter is uppercase and the other letters are lowercase. And now we are moving forward towards the next step, that is checking impossible values. Now in the presentation, I have already explained you that the proper handling of the impossible values and the replacement of impossible values will be done in the later stage, that is data pre-processing. Here we are only checking the impossible values and we will replace by standard invalid value placeholder, that is NaN, not a number. So when I expand this particular section, now for checking the impossible value and filtering them out, we need to understand this particular line of code. So let's understand this. Data.lock row condition, column name, where .loc or .lock means it filters the data frame. So this .loc applied over the given data frame data will filter the data frame on the basis of this row condition. So we have to write the row condition, we have to write the name of the column over which the condition is applied, and this data.lock will filter out the rows for us. It will fetch the rows only according to the given condition. So data.lock data size SQFT less than equal to 0, size SQFT equals to np.nan. So the very first column we are checking is size SQFT, that is the size of the houses. Obviously, we know that size of the house can never be less than or equal to 0. That is an impossible value. So we need to replace those values with NaN. So we have written data.loc as it is. Now we are considering the column data size SQFT, which means the size SQFT column of the given data frame data. If the values contained in this particular column is less than or equal to 0, then that will be replaced by np.nan, not a number. And here we need to write the column name. So we have written the same column name, that is size SQFT. In this way, all the impossible values in the column size SQFT will be replaced by np.nan. So when I execute this cell, all the values will be successfully converted into np.nan, only the impossible values. Now let's talk about this particular cell. This time we are checking the number of bedrooms column. If the number of bedrooms is less than equal to 0, then those will be replaced by np.nan. So let's execute this cell also. And all the impossible values in the bedrooms column will also be replaced by np.nan. Now the last cell under this particular checking impossible values is data.loc, data, age years less than 0, age years, np.nan, which means if the age of the house is less than 0, it will be replaced by np.nan, because obviously the age of the house can never be negative. But this time the age of the house can be equal to 0 if that is a very new house. That is why we have not written less than equal to. We have written only less than. When we execute this cell also, all the impossible values in the column age years will be converted into np.nan. And in this way, we are done with this step, checking impossible values. Now it's time to check the invalid labels. Now in the presentation, I have explained you, if the label is invalid, then we have to delete the entire row associated with that particular invalid label. So, if the label contains any impossible value, or if the label is missing, then we have to delete the entire row associated with that label. And in the house price prediction dataset, price USD is the label. So, this is the code I have written for checking invalid labels. And the same thing I have mentioned in the comment, checking invalid labels. Let's understand the first line. Data equals to data.dropNA subset equals to price USD. Subset equals to price USD means we are only considering the column price USD because it is our label. Now, data.dropNA means dropNA function is applied over the given data frame data. Now, what is the meaning of dropNA? DropNA deletes all the rows containing the missing values. So, if the subset, that is price USD, contains a missing value, or if the price USD is missing, then it will delete the entire row associated with that particular missing price. And the whole result will get back to the given data frame data. So when I execute this line, all the rows associated with missing label will be deleted from our dataset. Now, the next cell keeps only rows where price USD is greater than 0. Obviously, price USD should always be greater than 0. It cannot be less than or equal to 0. That is why we will keep only those rows in which the price USD is greater than 0. So, data equals to data.query price USD greater than 0. So, query function will fetch out all the rows in which price USD is greater than 0, and that result will be stored in the data frame data. So, basically, the data frame data is updated with the rows only having the price USD greater than 0. So, when I execute this cell, the data set is now containing only the rows having price USD greater than 0. And in this way, we are done with checking invalid labels also. Now we can reanalyze our data. If we check the shape of the data, we are getting 120,6. Now, after performing all these data cleaning operations, number of rows is 120 and number of columns is 6. Now, if I check how the data looks like now, this is how the data frame data looks like. And in this way, we are done with the practical implementations of all the operations of basic data cleaning. Now let's get back to our presentation. So in this way, we are done with the third step of machine learning pipeline, that is data cleaning. Now, in the next lecture, we will understand and implement the fourth step of machine learning pipeline, that is data splitting or train test split. So this was all from my side for this lecture. Thank you, and I'll see you in the next one.